Hello viewers, welcome to another edition of Brain Maths. In this video, we want to look at SURD. What is SURD? SURD is the mathematical way of writing rational numbers that are positive. That is, if you are given the square root of a positive number like 3, and you want to express this in a mathematical form. Firstly, we all know that the square root of 3 is going to be 1 point particular numbers. But instead of writing this 1 point, whatever is coming after it, we could leave our answer in this form by saying 1 point whatever is square root of 3. For example, if you are given the square root of 12, it is also believed that we cannot get an actual number for square root of 12 because it is also going to give us 3.5 something. And we don't want to write it this way. So it is better for us to look for a way to simplify this square root of 12 and make it look more beautiful mathematically than writing it in decimal. And mind you, whatever is given to us in this format that is not having a perfect square root will actually lead us to decimal numbers that have no end, because this one may be 3.5678 and so on. So in that wise, we have introduced SURD into mathematics. Now let's look at the rules of SURD. Rules of SURD. If you are given A times B, this can be broken down and be rewritten as square root of A times square root of B. For instance, if you have square root of 25 times 9, we can break this further into square root of 25 times square root of 9, where each one of them stand separately. And this will lead us to 5 times 9. 5 times the square root of 9 is 3, which is 15. And if we decide to solve this directly, we are going to have square root of 225, which is also 15. You can see that they are giving us the same answer. And also, this is rule number 1. Rule number 2 says, wherever you are given square root of A divided by B, this can be written as square root of A over square root of B. For example, if we have square root of 64 over square root of, say, 9, square root of 64 over 9, we can break this into square root of 64 over square root of 9, which is equal to 8 over 3. So this is another way of writing our SURD. Also, these are the two major rules of SURD, but we have to note that as we have the rule for multiplication and division, the same thing is not applicable to addition and subtraction. We cannot say, note that, number 1, square root of A plus B is not equal to square root of A plus square root of B. Let's take an example. If I say square root of 25 plus 9 as an example, this can never give me square root of 25 plus square root of 9. No, because the addition of these two here is actually 34, which is not equal to 5 plus 3. If you add the square root of this independently, you are going to have 8. And I'm sure you know that square root of 34 is not even up to 6, not to talk of getting close to 8. Also, square root of a minus b is not the same as square root of a minus square root of b. For example, as well, if you have 25 minus 9, under this, we cannot say it is equal to square root of 25 minus square root of 9. It's not possible. 25 minus 9 here will give us 16, which is not equal to the square root of 5. 25 is 5, and the square root of 9 is 3. So square root of 16 is 4, and that is not equal to 5 minus 3, which is equal to 2. So from what we have seen here, the rule for multiplication suffices that whenever we have a times b having a square root, we can break it into square root of a standing independently of b. And also, whenever we are given square root of a covering both a and b as division, we can also break them into square root of a standing independently of b, and we are still going to get the same answer. So if you look at the other side, the addition and subtraction do not work the same way with multiplication and division. We want to try and simplify these SURDS on the board. The first one says square root of 54. The closest square root to this, which is a perfect square root, is 49. So there is nothing like square root of 54, but we have to make it work. So therefore, you think of two numbers, that is two numbers that is containing a perfect square that you multiply to give you 54. What are the two numbers? We say 9 times 6, 54. 9 is a perfect square, and 6 is ordinary rational number. So this is going to give us the square root of 9 is 3. We are left with square root of 6. So you are going to rewrite that as ordinary square root of 6. And I think this looks beautiful mathematically. And this is going to be our answer in short form. The second one says square root of 40. For this, we still think of the product of 40 that is going to contain a perfect square root. And that is going to give us 4 times 10. 4 times 10 is actually 40. We have 4, which is a perfect square root, and that is going to give us 2. We cannot break this further, so we write it as root 10. Then the third one is square root of 300. For this, we are going to think of two numbers again. We can say 25 times 12. You can also say 100 times 3. If we take 25 times 12, for instance, let's take 25 times 12 firstly. Now, if you look at this 12, you will see that we can still break 12 further into 4 times 3, which is another perfect square. 4 times 3. So, in this one alone, we have 25, which is going to give us 5, and square root of 4, which is going to give us 2. So, we are going to have square root of 25 times square root of 4 times square root of 3. And that's all together will give us 5 times square root of 4 is 2 times root 3, which we cannot determine. And 5 times 2 is 10 root 3. And if we choose to do it the other way around, the one I mentioned earlier, let's see if we are going to get the same answer. We have 300, that is giving us 100 times 3. 100 is a perfect square root, and that is 10 root 3. So whichever way you go, you are still going to arrive at the same answer, provided you choose the correct multiples of whatever is given to you. Try to solve these problems on your own. We have square root of 250. Break it down and write your answer in short form. We also have square root of 245 and square root of 4m square n. Try to solve each and every one of them on your own. After solving, leave your answer in the comment section. Don't forget to subscribe to the channel if you have not done so. Until I see you again, have a wonderful day.